In my project, I investigated block equations, spin echo, and rotation. Furthermore, I analyzed the effect of the T1, T2, TE, and TR on magnetization vectors and the phase of it. First of all, I started block equation, and these are the formulas of block equation, and this one also. I plot four different graphs to observe the change which is created by T1 and T2 in block equation. I took the first one as a reference and I changed only T1 in the second, T2 only in the third, and both in the fourth. When figure 1, figure 2, and figure 4 are compared, it can be seen that when T1 decreases, MZ can reach steady state early. When figure 1, figure 3, and figure 4 are compared, it can be seen that when T2 decreases, MXY can reach steady state early. It means that in block equation, transverse magnetization starts from 1 and in time it approaches 0, as you can see in the figure. For MZ, it starts from 0 and in time it approaches 1, decreasing M1 and M2 to help magnetization to reach the steady state, and it can be seen also from the formulas of it. Second one is rotation. In rotation, the situation changes according to the rotation axis and initial magnetization. I presented three examples in this report, and according to these three examples, I analyzed the change in magnetization levels after altering independent constant T1 and T2. In addition, I plotted the 3D graph of the rotation magnetization, but I will show that later. And this for example 1. From both formulas and the graph, it can be understood that Mx doesn't affect from T1, but when T2 decreases, it reaches steady state early. My and Mz affect from both T1 and T2. Figure 7 is better for both Mz and Mz according to reaching steady state than others. For example 2, all of the magnetization vectors are only affected from T1 because when initial magnetization has component on z-axis. However, my equals to 0 always in this expression. It can be understood from that figure 9 and figure 11 are exactly the same with each other because in there only T2 is changed. For example 3, Mx is affected from T2, My and Mz both affected from T1 and T2, and these figures and the formulas show it.
Let's look at the 3D graph of the examples. This is for the first one. This is for the second one. And this is for the third one.
My last topic is spin echo. 90-degree pulse applied to the magnetization which is in the transverse plane. Then the spin vectors begin to fan out because of frequency differences. When Te over 2 time passes, 180-degree pulse has been applied. This pulse reverses the phase about P. At the time Te, the spins replaced because of the slope of the phase remains same. It means that spins come at the same position in Te. In spin echo, there are more variables which affect the magnitude than block decoration and rotation. The number of spins is one of them. The program creates random spins at every floating time with the numbers that I gave. I increase the spin number in order to observe the change in phase graph. The other values remain same, so magnitude graph doesn't affect from the change, but we can see the change in phase. When Te is changed, the spins rephase in different time. They rephase after Te time. In first one, it's 20 seconds, and the second one is 120. When T2 is increased, the magnitude should reach steady state later because it is the T2 decay. We can understand from the first one and the second one. First one can reach steady state early. When T1 is increased, the magnitude isn't affected from this change because the magnitude doesn't depend on T1. This is the end of my presentation. Thank you.